Let's say that a new business requirement comes in for our application, and the product team wants users to have the ability to recommend different coffees, and whenever that occurs, we need to add a new event to the database that can be used later for data analytics purposes. So we are going to need two things here. We have to provide a new endpoint that allows users to recommend coffees, and we are going to need to store the event after the previous call finishes. In order for this whole process to succeed, we need both operations to be successful. Otherwise, we may have inconsistencies in our database. This is where transactions come in. A database transaction symbolizes a unit of work performed within a database management system. Transactions are a reliable way to accomplish multiple tasks independent of other transactions. Note that there are other advanced techniques which leverage nest-scoped providers and interceptors to automatically wrap every write query in the transaction. But we'll cover those techniques in the later advanced Nest.js courses in the future. For now, let's keep it simple so we can conceptually understand everything first. Before we get started, let's create this new event entity that we use to signify events that occur in our application. Let's create this new entity with the CLI and put it in an events folder. In a real-world application, we would want to create and wrap this entire domain in a nest module so that everything pertaining to events, such as services, controllers, etc., are isolated. But for now, we'll skip that as we don't need it at the moment. Just a reminder that we are passing the nospec flag again, so that the CLI does not generate a test file, as we won't need them for entities. Now let's open our newly generated file and define corresponding properties. Also, and this one is important, let's make sure that the name of our class is event without the entity suffix, as we don't want the word entity in our database collection name. For our event schema, let's keep it simple and add a few basic properties: type, name, and payload. Payload is a generic property where we will store events payloads. These payloads will essentially be a dictionary filled with values of any type. For our schema, we are going to use the prop decorator we've already seen, but with one new addition here for payload. Since this has values of any type, Mongoose offers a mixed type we can use here that essentially means anything goes. Use this as a last resort, and whenever possible, try to have your types always be known. Lastly, we need to make sure we extend our event schema definition with the document class from the Mongoose package. Now that we have our class set up, let's create a real Mongoose schema. For this, import the schema factory class from Nest.js Mongoose, and let's call the createForClass method, as we did in previous lessons, to generate a schema based on our event class. Just like when we made our coffee schema, let's not forget to add event to the Mongoose module for feature array in the coffees module. Next, let's make sure we add this new recommendations property we talked about to our coffee schema definition. So let's add an additional prop with the name recommendations of type number and set the default value to 0. Great! Now that we have our event and coffee classes set up, let's get back to our coffee service. In order to create transactions, we are going to use the connection object from Mongoose. Let's inject connection into our coffee service constructor using the inject connection decorator, exported from the Nest.js Mongoose package. For our second dependency, let's inject the event model we just made again, using inject model, as we did in previous lessons. Now, let's use the connection object to create our first transaction. Let's start by creating a new method in our service, async recommend coffee with one parameter, coffee instance. Inside our method, we can see we are first creating a new Mongoose session. Once we have it established, we can start the transaction process. We want to wrap our entire transaction code in a try-catch finally just to make sure if anything goes wrong, our catch statement can roll back the entire transaction. Inside our try statement, you can see we are increasing the recommendations property on our coffee and creating a new recommend coffee event, and then using the save method on both documents to save all of our changes to the database. In our catch statement here, if anything goes wrong, saving either document, we are catching the error here to prevent inconsistencies in our database by rolling back the entire transaction. Lastly, the finally statement is used to make sure we end or close the session once everything has finished. And that's it. Just like that, we can create transaction statements that can help us achieve multiple actions to our database, ensuring they only happen if everything is successful.